Hi everyone, my name is Aman Agrawal. Along with my team member Amit Kumar Yadav, I am going to represent my final year project under the supervision of Professor Ganesh Kumar Yadav. Our project ID is 42 and our project title is Optimizing Routine Collection Efficiency in IoT based garbage collecting monitoring system. Now we have to further proceed to the introduction part of our project. With unprecedented population growth and urbanization increasing, waste is one of the most important problems in the countries that are still developing. Nowadays, proper waste management is most important problem that the world is facing. In most of the cases, you will find that trash can is filled with trash and lying nearby. This causes to the spread of some deadly diseases in that particular area. All of these issues are due to a lack of coordination and communication between members of the garbage team. This study also showed that waste management can be much more efficient if the waste is separated at the source and then disposed of separately in landfills. Therefore, there is a great need for proper waste disposal. When the garbage is almost full, the workers will come and collect the garbage. Now, there is a ease with which developers, innovators, and researchers may test and innovate with the IoT platform is fulfilled by the availability of publicly available hardware and software resources. Automation is familiar with almost everything in our lives, so it has revolutionized and made it convenient in our daily lives. Now, further, Amit will explain the implementation and coding part of our project.
So in this system that we are making, we have an ultrasonic sensor that is placed at the top of the dustbin that is used to detect the level of the waste that is present inside the dustbin. And then it sends notification to empty the dustbin once it gets filled via the ThinkSpeak app or ThinkSpeak API or Blink app. So ultrasonic sensor will detect the live status of the garbage, and then NodeMCU will send the data to the ThinkSpeak cloud and Blink app. We have used ThinkSpeak to visualize the data in a graphical format and to check the status remotely, whereas Blink is an app that will also show us the level of the dustbin remotely. For local users, we also have a LED screen for local users. Now I will be playing a video of our hardware doing full function. So this is the video that I will be playing. So this is how our device looks like. Here we have got a ultrasonic sensor that will measure the depth of the garbage that is filled inside this dustbin. Then we have got a buzzer that will alarm the sound if the level is above 85%. Here we have also Arduino Uno, then Node MCU. This is Node MCU, and then this is LCD screen which will show how much data is filled inside this dustbin, and if it is 95% more than 85%, then this buzzer will alarm for the local users. For that we have to first upload this code to this to our hardware, and in our case we have already uploaded it to this hardware, so it will simply run. So here I will show you again. This is 15% right now 60%. Now when it is 95%, it is giving the sound of beep, this buzzer. So this is all about our project, and then this data will be sent to ThinkSpeak API. As here we can see, this is ThinkSpeak API. This data is being uploaded to this cloud, that is ThinkSpeak API. Here we can see this 75% on date May 26, 2022, level 75%. Then it has increased to 75% and 90%. So these are the graphs that is shown on this.
Then from here what we can do is we can export this data, and then we will be using Jupyter notebook.
So this was our video for the result. Before discussing about the result part, I would like to show our coding. So first we will be seeing our Arduino coding. So this is Arduino 1.8.19 in which we have written our code. We have included software serial.h. Then we have defined buzzer 5, trigger pin 17, echo pin 16, and my Wi-Fi SSID is project. Then password is this. This is my phone's hotspot from which I will be connecting this. This is the API. So this is a full coding of our Arduino 1.8.19. And then after this, what we will do is we will connect our device and then we will click on the upload button. And then this will be uploaded on our device and then it will start the full working. Now moving to the Jupyter coding. So this is Jupyter coding. In this, we have already run the coding and now we will be showing the full coding of our project. This is the graph of k-means label. Then this is calculated by standard deviation formula, which is given 648.6735. The member of set of x differ from 6 minutes 16 seconds, which is difference of dustbin fill time from one dustbin to another bin. And the range is 2089.0. This is another graph that we can see here. We see that dustbin 6 is nothing but dustbin near cafe is getting full soon. Hence, dustbin number 6 is having high anomaly and new dustbin allocation is required nearby. And the location of this is given here, region, latitude, and longitude. And this is the heat map of our project. This is another graph in which shows K value is correct as after 4 variance is neglected. This is obtained at PCA 3 and hence we choose. And at the end, dustbin number 6 causing anomaly. So standard deviation of x1 and x2 is 2.2912. The member set of x1 or x2 differ from 2 minutes and 29 seconds, which is difference of dustbin fill time from one dustbin to another bin. Hence, we observed reduction in standard deviation. That is all about our Jupyter notebook codes. Now we will move back to the result part. So after seeing that coding, we have discussed that dustbin number 6 is having very high anomaly and new dustbin allocation is required nearby. So this is what our project is doing. It is optimizing the output of this project. Further, Aman will conclude our project.
Now we have come to the conclusion part of our project. We have proposed a system in which we develop a hardware consist of ultrasonic sensor that detects the dustbin level. Will send clean-up request. With the machine learning and k-means clustering, we can optimize the data to determine whether new dustbin need to be installed. The proposed system provides integration of our various modules such as ESP8266 Wi-Fi modem, ultrasonic sensor, an Arduino board, GSM module, which is a low-cost and economical intelligent garbage collecting system. The big advantage of this system is that it is implemented using the cloud ThingSpeak database. This database is open source for collecting large amounts of waste at each site and immediately returning it to the garbage collecting mobile application. Now we have to come to the application of our project. minimized operation cost and long-term saving, ability to collect apparently all waste streams, flexible system with the ability to easily adapt to changes, minimized uses of garbage collection trucks in urban areas, minimized noise, aesthetics, pollution and odor problems, release of surface space for community needs for development, enhanced safety for collection workers. Thank you.
Thank you.